Welcome to Lucky 7 Auto's first YouTube video, and it concerns this 2012 Caprice PPV all aluminum 6.0 LS engine. Has 180,000 miles on it, been well maintained. Had no problems until a catalytic converter melted down, and because of that, we wanted to inspect the engine because of the mileage. There's always concern about DOD AFM stuff going bad. And so we took the dive and pulled the heads off, pulled the lifters, and we found a couple of lifters that the roller, the actual roller face, had brindled, and small pieces of metal had flaked off. Technically, they were still good, and I'm sure if it wasn't for the catalytic converter, I would still be driving this car. But you get spooked with all the stories about AFM and DOD. So this car, 180,000 miles, perfect. There we go. So also, hey, we are really blessed in that we have both Holdens imported into the United States. So GTO over here, 40-something thousand miles on it, runs really great. Not planning on working on that one anytime soon, knock on wood, but it's pretty interesting that we wound up with two Australian cars in our parking lot. So let me pop inside. Now, the reason I'm doing this video, there are two reasons, and I think on one of them, I'm going to be the first one to even talk about this. I am a Generation 1, Generation 2 small block Chevy guy. There you go. I have read Smokey Yunick and all these other great hot rodders forever, and when I work on a motor, there are just certain things that I do. And I will tell you what, when we've done work in the shop replacing heads, but this is the first time where I've disassembled one and actually looked at the ports and the seats and all that stuff. So this was a first for me. Got the heads off, and I will tell you, as a Generation 1 guy, these things are beautiful. They're rectangle port. There we go. And the castings are as good as you could ever hope for out of a factory. The casting shift is very consistent and very minimal. Everything looks great. My goal with this build, we decided to go through the motor, pull the crank. The crank is standard after 180,000 miles. The bore is standard. There is no ring ridge anywhere. This motor is absolutely amazing for that many miles. Totally surprised and happy. Okay, there you go. So normally with Generation 1 heads, there are always steps underneath the exhaust valve, intake valve. The short side radius on the intake is rough. It is not smooth. It is not anything close to optimal. These heads, man, I didn't touch the ports. I don't see any reason to. This is not a high horsepower build, and honestly, the ports look bigger than they need to be for what I want this engine to do. So, what do I do? What do I look for in ports? Okay, intake. The roof of the valve, the roof of the port, that's high-speed stuff, and you don't want to screw that up. You want that nice and smooth, okay? Whether you're looking for horsepower, torque, whatever. You don't want air getting disturbed and tumbling as it comes in. On these heads, as I pulled my finger across the high side, it would catch on a ledge caused by the seat not matching up with the casting. And so we had a ledge coming in that way, but going out, we had another kind of ledge going that way. I didn't want this ledge because it was into the airflow. So I got a stone, and I highly suggest you use a stone if you do this, and because it's slower and gives you a lot more control. Anyway, I took a stone, blended the valve seat into the head, and did not remove any aluminum. Now, on the other side, on the slow side, where the velocity is down, there was a ledge going back that way. And that is what I want. I do not want reversion. We're not going to get so much reversion on this side because things are moving fast. But on this side, they're slow, and it's easier for them to turn around and allow reversion. So there was a step, if you push your finger in the port, it would catch on that step. On this side, it would catch coming out. Don't want that on the coming in, but going out, that can help prevent reversion, even though it's not a whole lot. I would not put a step in there, but I didn't take that one out. Now, I did modify the valves. Okay. David Viazrd, I took a lot of his advice about this, and there we go. This is my first attempt at putting the groove in the face of a valve. And if you go look online, you will find this picture. And I put a little more information. I wound up, I found 120 thousandths, give or take, might have been 125, profile cutter, which is basically a round cutter, except you can't use the back side of it. If you look at this drawing, you can figure out how big it needed to be. Okay, so I was going to do the stock valves, except there was 15 thousandths run out on the face of these. So if you look, man, it's barely touching in 40, 50 degrees. So I had to ordered a new set of valves, and I tell you again, man, these heads are great. The original valves are back cut. The ones that I got were not. And so, you look at the picture, I actually added, he did not put it on this diagram, but I came in and put a 45-degree back cut on it. I really like Eric Weingartner's videos, and he will tell you that the back cut matters, but I'm going to tell you, under 3,000 RPM, I'm not sure how much it matters, okay? I got new valves because if I were to make a 25 thousandths deep cut all the way around, that was going to be a 40 thousandths deep cut halfway around, because there's 15 thousandths of an inch run out on the face of the original valves. So, modified the valves, and you can see that ditch. That ditch serves two purposes. One, it helps the valve seat at high RPM. I'm not worried about that. But one of the things David Viazrd noticed when he first did this was that it helped the engine get on the cam hundreds of RPM earlier. And that's what I want. I want torque, I want horsepower beneath the peak. And that's why I did that. Okay, now if you look at the exhaust valves, you can see they're shiny. And that is a 45-degree cut on the edge of the exhaust valve. And I finally found a picture that talks about it. If you are proficient with a lathe, you can put a radius edge, and I'm sure that's worth something. I'm not that good. So what I did was I put a 45-degree chamfer. The only thing, do not get greedy. Don't cut into the margin. On the stock valves, there was plenty of margin. Off we went. Now, the other thing they talk about in this picture is to do a back cut, and that is to, do a 45-degree back cut. And on this picture, it says to narrow the seat. It does help flow. I am not worried about that. This head is going to flow more than I will ever need under 3,000 RPM. But listening to David Viazrd, somewhere, and I cannot find the picture or the source, but this was had something to do with anti-reversion, and that's what I am all about here. He said, come in. I say he. If it's not you, David, I apologize. Someone said, come in and ditch cut on the back of the valve. Don't get crazy, but you want that to impede flow out of the head. I think it's Eric Weingartner that said exhaust ports generally flow better into the engine than they do out of the engine. And that's not a good thing. Okay, so back cut, put that little ditch cut in there, and that can help. I believe that's going to help horsepower under, max torque. Okay, now the other thing I noticed with these heads, and let me take a second and stand this thing up. All right, here we go. These are D-port exhausts, and they do that D-port because the bottom of this, you will see, again, David Viazrd has a few videos out there where even though air is coming out along the top, which is the high-speed portion of the port, air is actually getting sucked in here and just kind of going in and coming back out like in a big vortex or loop. And you don't want air going into the engine. So what GM did on some of their big blocks, they put a vane in here, and that vane takes up that dead airspace. What they did on these heads is they made it a D-port. But here we go. You look at how much material is around that port. Okay, and compare it to the gasket. Gasket is pretty big around there. But, whoa, excuse me. Let me see. Put the gasket on here, and my worry, as I'm looking at some of these ports, I do not want any of the exhaust manifold to protrude, to be smaller than anything in that head. I also want to make that ledge here more prominent. So what I'm going to do, you can't even see where I scribed, but I laid the gasket over here and I scribed around where the gasket was, and wow, the shiny part, that's where it is. I'm going to go in, I'm going to grind out this bottom part so that that D is more pronounced. This is where you're going to get reversion. So I really want to step here. I'm also going to grind out the top. Again, man, I'm worried about reversion. So ideally, I'm going to have a step going back into these heads right here. Or I should say right here. The face of the head, any air coming back in is going to hit, and it is not going to have an easy time getting back into the chamber. My hope is that it will help the computer be happy, less reversion, and not so much dilution, okay? Really, we are trying to keep mileage what it was with the DOD and AFM, and we are getting rid of that. So we are putting I'm going to say better cam, better, a little more lift, actually slightly less duration, and a lot less negative overlap, but we don't have positive overlap. So that's why we're doing this. We're trying to maximize torque, off idle up to, all these mods probably stop helping at peak torque. Okay, these are not horsepower mods. So keep that in mind. All right, so let me take a break and move over here. As a Gen 1 small block Chevy guy, man, you own a grinder. You are cleaning up the holes going into and out of the oil filter cast part of the block. You're cleaning up the main cap where the oil pump feeds into the block. You're matching holes here, matching holes there, all that kind of stuff. An LS engine, there's not a lot going on, and you really don't hear people complaining about the oiling system. Well, as a Gen 1 guy, what I was told is every 90-degree turn, oil has to make you lose either 5 or 10 psi. It takes energy to turn a sharp corner. And if you look at this block, I will tell you, oil comes in here, goes here, right turn, 5 psi. Goes here, where the plug used to be, right turn, 5 psi. Makes a long run down here, and I'm not going to mess with that at all. I'm still trying to figure out what I can do down here, but it comes in, goes up. There's a 90-degree turn at the bottom of this hole. This goes into the oil pan, goes through the housing. Haven't looked at that too much, but if there's anything I can smooth out there to help oil flow, I'm going to do it. Comes back in here, hits another 90-degree turn. Every 90-degree turn costs you some oil pressure or volume when you need a lot of oil moving. I don't think I'm going to do anything at the back of the block. I've not convinced myself that I want to touch anything there. But what I am going to do is get a burr. I have a burr that's almost the same size as the hole. I'm going to come in and I'm going to radius right here. Now, what I'm hoping, I haven't done this yet, and I'm going to post this video, and if anybody has hit water, oil, air, or anything, I hope they tell me, and then I won't do it. So I'm going to wait a couple of days and see if anybody has tried this before me. But my hope is that once I round this out, is that I can take a long ball end burr, just come in the hole, and catch that 90-degree turn right here. And my hope is that I can make it where the oil comes in and does more like a 45-degree turn into the main galley that runs down there. Obviously, I can't do much down here. I can radius the corner where it comes up. I can radius the corner where it goes out. But honestly, not going to make as much of a difference there. But this looks like the place that you can make some difference with. I am not going to talk about porting oil pumps. I am going to do that. There are tons of videos out there. Go find one. And that's it. There you go. A video on low-end torque, not gobs of horsepower, and a video about improving the already very, very good LS oiling system. Hope you learned something. And again, if anybody has done this oil mod and has regrets, please post. All right. If there are, I'm going to unpost this video. But this looks pretty straightforward to me. All right. There we go. Only other thing, let's see.